This is a presentation on Reductio ad absurdum, an argument form that's sometimes called proof by contradiction or indirect proof. To understand Reductio ad absurdum, we have to first remember the definition of validity. An argument is valid when it could not possibly have all true premises and a false conclusion. True premises and a false conclusion are impossible in a valid argument. Remember that a contradiction could not possibly be true. So, if you can show that all true premises and a false conclusion led to a contradiction, then you would have shown that the argument is valid. That's what reductio ad absurdum is. It's the presentation of an argument in which one derives a contradiction from the premises and the negation of the conclusion. So pretend what you're trying to prove is false and use the premises to show that leads to a contradiction. Now we'll consider a few examples of reductio ad absurdum. The easiest examples to come by are mathematical examples, but I'll try and give you a few others first. You've heard the silly question, what happens when an unstoppable force meets an immovable object? I think the point of that is to make you think, that's impossible. There couldn't be two such objects. One important feature of reductio ad absurdum is that a contradiction be generated. In the case of the unstoppable force and the immovable object, there really isn't a contradiction generated. What would happen if those two objects met? Here's a better question. What would happen if an unstoppable force met an immovable and impenetrable object? That leads to contradiction, and we've shown that there couldn't be those objects meeting. Here's another example that's only slightly less silly than the last one. Maybe at one point an English teacher of yours said that there's an exception to every rule, and you thought that has to be false. Here's how you could use reductio ad absurdum to prove it. The first step in a reductio ad absurdum argument, or a proof by contradiction, is to assume that what you're trying to prove is false. So in this case, we're going to assume the opposite of what we're trying to prove. We're going to assume that the statement, there's an exception to every rule, is true. Call that statement X. So we start by assuming that X is true. A rule is just a true universal statement. That means that X is a rule. X is a universal statement, and it's true, so it's a rule. But if X is true, and every rule has an exception, and X itself is a rule, then X must have an exception. Another way of saying that is that there's a rule that doesn't have an exception, but 1 now contradicts 5. So our assumption can't be true. Now here's the mathematical example that I promised you. Prove that division by 0 is not acceptable. You remember, if only vaguely, that you shouldn't divide by 0. If you want to prove by reductio ad absurdum that division by 0 is not acceptable, the first step is to assume that it is acceptable. We'll need some other premises in this case. You remember from algebra that equality statements are true when you do the same thing to both sides. So if the left side of the equation equals the right side of the equation, then you can add 6 to both sides. Or you could divide both sides by 7. Or you could multiply both sides by 17, and what you'd get would still be a true statement. You wouldn't argue with me if I told you that 2 times 0 equals 3 times 0. Both sides are equal to 0. You also remember maybe vaguely from algebra that multiplying and then dividing by the same number cancels. So if you multiply a number by 3 and then divide by 3, you get the original number. You also know that 2 does not equal 3. If you put premises 1, 2, and 3 together, you get this. 2 times 0 divided by 0 equals 3 times 0 divided by 0. Because you know that 2 times 0 equals 3 times 0. We're assuming it's acceptable to divide by 0. So we could do the same thing to both sides and preserve the equality. But by premise 4, multiplying by 0 and then dividing by 0 would cancel, and we'd get that 2 equals 3. But 2 equals 3 contradicts 5, so we know that either one of our premises is false or that our assumption is wrong. One of the more famous philosophical examples of reductio ad absurdum is Anselm's presentation of his ontological argument.